chapters where you just fill in and people asking questions. So they're oftentimes done in paper where people give you a piece of paper and a pencil and say, answer this question, like you would do on the MMPI. Or you can fill these things out on a computer, just asking people all sorts of questions about their mood, about their thinking, about their behavior, about drinking, about their relationships with other people. This is a big part of cognitive behavioral assessment. Now, neurobiological assessment in recent years has come to play a bit more of a role in our field. You still can't do a brain scan to make a diagnosis of a mental illness, although you can do a brain scan to see if somebody has a nail in their head, which is what's illustrated there. But we can't yet, using the best tools at brain imaging, determine that somebody, say, has depression. Now, as we go through the semester, we'll see lots of pictures of brain scans, though, that show particular areas of the brain that are not maybe working properly in people who may have depression. But it's not specific to depression, and we can't make a diagnosis based on that. But it can be helpful if, for example, you want to know if somebody who is having some cognitive problems, and is it because they also have depression, or is it because they have a traumatic brain injury? You may have a veteran who's just come back from the war in Iraq or Afghanistan who is experiencing all sorts of symptoms, and you also want to know, did they have some sort of traumatic brain injury? And imaging can help. There are different kinds of brain imaging that can be done. To look at the structure of the brain, which is what that top picture is illustrating there, you would use something like a CAT scan or an MRI, which stands for magnetic resonance imaging. So that just shows you the structure. If somebody has a lesion in a particular area of the brain, that will show up quite clearly using one of those two techniques. If you want to know how the brain is functioning, like somebody is actually reading something or they're looking at pictures, what's happening in their brain, then you might use something like a PET scan, and that's illustrated here in the bottom right-hand picture, the very colorful one. Here, you do a PET scan, you've got to inject a substance, and what a PET scan does is gives you a pretty picture of how your brain is metabolizing glucose, kind of the fuel that keeps our body and brains going. The more color you see in a particular area, the more glucose metabolism is going on in that particular area of the brain. And then if you want to look at both the structure and the functioning of the brain, that's where you would look at fMRI, functional magnetic resonance imaging. So here, we have a scanner here on our campus. Maybe some of you have even been in it and done experiments in the scanner where you might be asked to look at some pictures or read some words, and we can take a look at the actual structure and see the different lobes of your brain, or see the hippocampus even, and the amygdala of your brain, and then we can also see what's happening with respect to blood flow in your brain. Our scanning techniques, even fMRI as advanced as it is, doesn't allow us to see neurons. The pictures aren't that good. We can't see the billions of neurons in your brain, nor can we see these neurons communicating with one another. But what we can see is changes in blood flow, and oxygenated blood in the brain. It's the bold signal is what fMRI captures. And the thinking is that the more you're using a particular area of your brain, the more your neurons are actually firing, the more oxygenated blood that area is going to need, and so therefore it's going to show up with those, in this case here in red. Those areas of the brain, those neurons must be really working here because there's more oxygenated blood that's going to those areas. So we'll see lots of studies using mostly fMRI as we talk about different disorders. Now, another kind of assessment that psychologists learn an awful lot about is neuropsychological assessment. So here, neuropsychological tests are tests that are designed to help identify if a particular area, region of the brain is not working in the way that it should. So this is an example of a neuropsychological test. Believe it or not, that just looks like a ridiculous number of letters, and it is. And what your goal in this test, if you're given this on a computer from this paper, circle all the letters A. You want to work as quickly as you can without making any mistakes. So that's what you would do. That's a pretty detail-oriented test. You would circle all the A's, and then you would score that, and you would be looking to see if people missed a lot of A's, and if they missed a lot of A's all over the place, that could be a problem in attention. Or if they missed a lot of A's in one particular area. So maybe it's the case that people got all the A's in the top and the bottom on the right side of this, but they missed every A on the left side. All of them. They didn't circle one. That might be an indicator of a problem called visual neglect, where people just don't see. So if, in my example here, people are missing things on the left side of this picture, that means that there's probably a problem in the right side of their brain in the visual areas. They've got visual neglect. Because if you remember, if you've taken any classes, you may learn that some of our brain function is contralateral, so our ability to see out of our left eye really is controlled by the right side of our brain. So that's just an example. Here's another example of a neuropsychological test. This one's called a digit symbol. And here you can see there's a key at the top, and then there's a bunch of symbols, and your goal is to fill in the appropriate number according to the key for those symbols. And again, I want to work as quickly as you can without making any mistakes. And so this is a test of attention and of vigilance, and so you would be scoring this for how many people complete in a certain number of times. This can tell you something about the frontal lobes. In particular, you look at the kinds of mistakes that people make in this kind of a test. And then here's another kind of test. You can actually play along with this one yourself. If you have a piece of paper, go ahead and pull it out. This is going to be harder to do on a computer, but maybe you can do it on iPad. Go ahead and what you do on this test is you would draw this figure. So if you have a piece of paper, you can just take a minute here to go ahead and draw this. And if I was the actual person giving this test, I'd be watching how you were drawing, the way in which you approach this problem. Do you start by drawing like a big rectangle, or do you start by drawing a circle, or the particular areas that you're drawing and other areas that you leave out? This could also tell me something about neglect, if you neglect the whole right side of the figure, for example. And usually you would be given unlimited time to do this, but we do not have unlimited time here, unfortunately. So then the next part of this test would be this, where I would ask you to get out a new sheet of paper. What you do is you flip over, different piece of paper. Now draw as much of that as you can remember. No cheating, please. As much of that picture as you can remember. All right, now you can, I'm going to put it back up here so you can see, but you can also refer to your original drawing to see how you did. Right. So what we're assessing here, this is called the immediate recall part of the test. And what I'm doing, this is a measure of visual memory. So I'm looking to see how people are able to remember visual things. And if I was doing this test, I would test you again 30 minutes later. So if you're not in a assessing visual memory. There are other neuropsychological tests that would assess verbal memory. So I might give you a list of words or have you read a story. So you read a story, then I take the story away, you tell me how much of the story you remember, 30 minutes later do another delayed recall. So visual and verbal memory recruit different areas of the brain to do these kinds of tasks. And so we could determine if there are particular difficulties you might be having based on your performance on these kinds of tasks. All right, cultural bias in assessment. The book talks about this towards the end of chapter 3. I think I'll let you read that on your own for about a time. I know a couple of people have questions that I was putting off, but it's an incredibly important area. I definitely want you to read that piece in the book. But the people who had questions that I didn't get to before, do you still have them? Yeah. She was asking about the self-fulfilling prophecy. We talked about that on Tuesday. It's one of the disadvantages of diagnosis. And she said, could I talk a little bit more about the evidence that isn't operating, but she had heard that there is evidence for that. So there's evidence in the world of self-fulfilling prophecies, just not in the world of mental illness. So telling somebody that they have ADHD is not going to cause somebody to have ADHD. Or telling people that, wow, you look really anxious about people, I bet you have social anxiety disorder. It's not going to cause people to have social anxiety. But we know much more about, we have much more evidence in support of other things. For example, in the case of ADHD, we know a pretty good amount about the genetics associated with ADHD. Much more evidence in support of it as a cause than simply telling people that they have ADHD and then they say, wow, maybe I do have ADHD. That doesn't cause there's self-fulfilling prophecy effects in other aspects of behavior, just not in mental illness. Somebody up there has a question I did.